Brian M. Scott for making me aware of this notation. The superscript notation, it really just means the non-positive integers. So we have dot -3 -2 -1 all the way out to 0. Now this listed is just what we would call the non-positive integers. This reads z superscript less than or equal to 0. And again, I found out about this at Math Stack Exchange. I don't think it's a super popular notation, but he said anybody that saw this would understand it. So I agree with that 100%. And I believe he is a mathematician and a teacher. Okay, now we're supposed to find all the non-positive integers that satisfy this inequality. Now you'll notice real quick, 0 is the only, it's a non-positive integer. And notice that n equals 0 is a solution. You guys can verify that. So n equals 0 is a solution. Very easy to verify. Won't waste the video time to do it. Is a solution. Okay. Now, also, we need to use the definition of absolute value, obviously. And so the only part of that definition that is useful here, I'll call it the absolute value of A, where A is any real valued expression. It could be anything at all that's real valued. It's equal to minus A. You can think of absolute value as distance, of course, as famous interpretation of absolute value that extends to the complex numbers. But it's equal to negative A if A is less than 0. And again, it's slightly technical definition. Anybody can do it in grade school. What is the absolute value? They just change the minus to a plus. But it's because it's the distance of the number from the origin. Okay. Okay, so now we're going to use that because these two absolute value expressions break at these values minus 1/2. When n is less than minus 1/2, 2n+1 would be less than 0, right? So that's why we have to place this minus sign here. And similarly, if n is less than 2, then this value between the two vertical bars is also negative. So that's why we have to see how we reverse this. This would be 6n minus 12, but if you apply a minus sign to that, it becomes 12 minus 6n. Okay, now a useful thing to note here is that whenever n is less than minus 1/2, it's also less than 2. So you can, all you really have to do is consider less than minus 1/2 since we're interested in non-positive integers. Okay, so this is the work. I replace both of them with what they're equal to based on, this is our original expression. See how the minus signs come in here and change things around a little bit? And you can manipulate inequalities just like you can manipulate equalities. We get to this stage here where we have minus n is less than or equal to 14. That's equivalent to n is greater than or equal to minus 14. That's very easy to see on the number line. Okay, so we know we have all the integers greater than or equal to minus 14. Y'all, and as a sanity check, you have equality at negative 14. And again, I'll leave it to you to verify that. But if you put minus 14 in here, you actually get equality. That's why this says less than or equal. All right, so how many of them are there and what are they? Well, 14 is the first one. And we were asked just to list them out, so I'll list them out, but we can also count them clearly. So minus 13. These are all the integers greater than or equal to negative 14. So we got minus 12. And it's ellipsis time. Whoops. We can do our ellipsis. Okay. Okay, and let's go to what? To negative 1? Actually, we can put 0 in. We've already noticed that, but we'll just go ahead and put it in. Right? And again, we're just looking for non-positive integers that satisfy the condition. So there are 15 of them. We were only supposed to list them, but we can also easily enumerate them, count them. So that's 15. 15 various integers, and it's actually the integers in this list. And I guess that was the question, right? So these are the only non-positive integers that satisfy this absolute value inequality. Now, again, I think any positive integer works. You can, yeah, it's pretty clear. Every positive integer works, it appears. I think you can verify almost certain it's true just by the looks of this thing without even thinking about absolute value, right? You got 6 times something here, then 3 times something. And if all the n's are positive, this right-hand side just looks bigger than the left-hand side for positive integers, right? But you do have to, that's not the same. Minus 15 would not work, minus 16 would not work, minus 17, and so on ad infinitum. Okay, this is the solution. There's 15 answers, and those are the answers. Let me know what you thought. This was a SMO problem. It's slightly modified SMO Junior problem, I think. All right, thanks for viewing.